All right, so today we're going to go into section 2.4, start talking about complex numbers today. Essentially, we're going to define what an imaginary unit is, what an imaginary number is, what complex numbers are, and then we're going to talk about adding and subtracting complex numbers and just multiplying complex numbers today. We'll add in dividing and those different types of things. We'll add those in tomorrow. So let's start out with just, if we want to look at taking the square root, if we have x squared equals 16. And how you go about solving something if you have x squared equals 16. Well, there's a couple ways to think about it. And if you just think about x squared equals 16, you talk about the concept of your variable is x, what numbers squared are going to give me 16? And the obvious answer is 4. Remember, when you square something, it means you're taking it times itself. So if we square 4, 4 squared is 4 times 4, which is equal to 16. And that one's usually pretty obvious. Nobody ever really forgets that one. But you also have to keep in mind that not only is 4 an answer, but so is negative 4. Because, again, if we square something and we're squaring negative 4, that means that I have to take negative 4 times negative 4, and negative 4 times negative 4, a negative times a negative gives us a 16 as well. So if you think about it, it makes sense to do both the positive and negative of your answer. Mathematically, to get rid of a square, you take the square root. So just like to get rid of multiplication, you divide. To get rid of division, you multiply. To get rid of squaring something, you take the square root. So realistically, we're just taking the square root of both sides. Keep in mind when you're doing that the answer is going to be both positive and negative 4 in this case. And the rationale as to why it's positive and negative 4 is really over there. Again, we always remember the positive part of it. The piece of it that always gets missed is making sure that you get the negative version of it as well. So then the question people always come up with, well, what if I'm just asked for the square root of 25? The square root of 25 is just 5. Okay? It's not positive or negative 5, it's just 5. You're not asked to find the value of something. That's a completely different question than if I say, find the value of x, if x squared is 25. Now you're solving an equation. Before you were just simplifying an expression, and it's two different things. Now the answer to this has to be positive and negative 5 because you're finding the value of a variable. And that's the distinction between those two things, as to one's an expression that you're simplifying, one's an equation that you're trying to solve for or find the answers of if you replace it. Okay? So then that leads us to something that you haven't been able to ever do. Say, okay, what if I have x squared is equal to negative 9? So again, logically, if you think about this, I need two numbers that are the same that multiply to be negative 9. And we don't have those. I can't say this is 3 times negative 3 because that's not what squaring something means. Squaring something means that you have to take it times itself. So logically expressing it, like we did that first one, you really can't do. Well, mathematically, can we look at it mathematically? Sure. I can take the square root of both sides of these. But again, now we have x is equal to the square root of negative 9. Well, you don't know how to take the square root of a negative 9, so I haven't really solved anything. Well, math is a pretty cool tool. So I could rewrite this as the square root of 9 times the square root of negative 1. We know what the square root of 9 is. The square root of 9 is 3. And I should have put plus or minuses in here. I forgot to put the pluses or minuses in there. So we know what the square root of 9 is. We know the square root of 9 is 3, but now we still have this square root of negative 1 kind of sitting out there that we don't know how to deal with yet. Okay? And throughout the history of math, it really wasn't taken care of until kind of later on, and somebody just said, okay, we need to be able to figure this out. How can we figure out what the square root of -1 is? And that's when mathematicians do what mathematicians do, and they start to make things up. Okay? Now, when mathematicians make things up that are not me, they make them up with the theory that they have to prove that they actually work and they actually exist. They're underneath, right there. See that pile of papers right there? Look in there for yours. And then you can go into that back room. So they have to go out and prove that these things actually work and they're actually needed and all of those different things. And obviously, the square root of -1 is something that is needed out there. So they come up with this. The square root of -1 is called an imaginary unit. Okay, so for your notes, the square root of 1 is an imaginary unit. And what we do is we replace the square root of -1 with an I. When we do that, then it becomes, again, an imaginary unit. So anytime you see the square root of -1, you can replace it with this imaginary unit, I. So if we go back to that last question that we had then, this square root of -9, I've got plus or minus 3 times the square root of -1. We can go ahead now and replace that square root of -1 with an I. So the solution to this becomes plus or minus 3I, where 3 is a real number and I is our imaginary unit. Now you can forever take care of taking the square root of negative numbers. Okay. So with that being said, once you do that then, once we've already done that, then we replace things with what are called, well, guess that's in a second. Okay, imaginary numbers. So if we want to look at these two examples, the first one, if we want to look at x squared equals -5, and we want to rewrite that, find the values of x that make this work. So we're going to take the square root of both sides. So we take the square root of x squared, that just gives us x. We take the square root of -5. The square root of -5 now is going to give us plus or minus the square root of -5. For purposes right now, that's plus or minus the square root of 5 times the square root of -1. The square root of 5 can't be simplified. If it could be simplified, we would simplify it. But it can't be, so we leave it alone. We know the square root of -1 is I, so the correct way to write this is plus or minus. I like to put I times the square root of 5. If you put plus or minus the square root of 5I, either of these are technically correct. Just need to make sure that that I is not underneath the radical symbol because we've taken it out. Again, I like to put it in front. Most of the teachers in this building like to put it in front. Okay. So if we have this x squared equals the square root of -72. So we take the square root of both sides. So plus or minus the square root of 72 times the square root of -1. Now we have to take this 72 and we need to break it down. So we do the factor tree. I'm going to pick 2 and 36 because I know 36 is a perfect square. 36 is 6 times 6. I don't need to break it down anymore because I have a pair. So remember, when you're breaking that down, that comes out. If it has a partner, it comes out of the radicals. So that gives us plus or minus 6. Square root of -1 is I, so I'm going to put the I right there. The 2 doesn't have a partner, so the 2 has to stay underneath. So our solution to this is x is equal to plus or minus 6i radical 2. And that's your solution for your x values. Again, making sure you don't forget that plus or minus part. It is missed a lot. Go ahead and find the solutions to x squared equals negative 96. This will give you practice on finding square roots. Remind you what we did a month ago. All right, so if we look at it, it gives us plus or minus the square root of 96 times the square root of negative 1. So if I break 96, 3 times 32, 16 times 2, 16 is 4 times 4. So the 4 has a partner. So because the 4 has a partner, it can come out. So I've got plus or minus 4. Square root of negative 1 is I. 3 and the 2 don't have partners, so you have to multiply them back together. So positive or negative 4i radical 6 should be your solution to it. Any questions with that one? Again, if it's breaking it down to 96, that's a question that needs to be taken care of. It's something we've already covered. So if you need help with that, make sure you come in and get some extra help with that. So now as you can see, we've combined real numbers and imaginary units. I is just an imaginary unit. When we combine them together, we come up with what's called an imaginary number. An imaginary number, that really doesn't need, that's kind of the same thing we've been doing. An imaginary number is any number bi, where b is a non-zero real number. So that's called an imaginary number. When you take an imaginary number and add it to or subtract it from a real number, you come up with what are called complex numbers. So a complex number, and it says it up in there, a complex number is anything that's in the form a plus bi, where a and b, those are real numbers. And the I is your imaginary unit. Okay. So A and B are real numbers, so that A is always just going to be a real number. This B part right here, okay, the B part of it has to be a real number, but the whole thing, this part right here, is really just an imaginary number. So it's got a whole number, it's got a real number part and an imaginary part. And when we rewrite complex numbers, it always needs to be the real followed by the imaginary. So this is always going to be real number followed by the imaginary part of it. So we want to be able to add, we want to be able to subtract, we want to be able to multiply, we want to be able to divide complex numbers and imaginary numbers. So the first thing there, the next thing that we're going to look at then is we're going to look at, okay, what if we want to find the sum of two complex numbers? So don't write it like that. Sum means to add. So if I want to take 4 minus 7i plus negative 11 plus 9i. If I want to take these two complex numbers and add them together, it's combining like terms. You're going to combine real numbers with real numbers. You're going to combine complex numbers with complex numbers. Think of it the same thing as if you were going to take 4 minus 7x plus negative 11 plus 9x. You combine the like terms. It's the same thing. You're going to combine real with real. You're going to combine the 4 with a negative 11 to come up with a solution for that. 4 plus negative 11 is negative 7. And you are going to take the imaginary parts, negative 7i and 9i, and you're going to combine them to come up with an imaginary part. Negative 7 plus 9 is 2, so that's plus 2i. So there is our imaginary part. So this is the simplified form of that sum of those two complex numbers. You combine reals with reals, imaginary with imaginary, just like you would do if it was polynomials. 4 minus 7x and negative 11 plus 9x. You combine like terms. Same thing when you subtract complex numbers. If I have 6 plus 8i minus 2 minus 5i. Just like if you're subtracting polynomials, you have to be careful with this. 6 plus 8i, I can just remove the parentheses. But because of the parentheses, I have to distribute that negative. So this is minus 2. A minus and a minus make a plus. So that makes negative 2 plus 5i. Now you can combine the reals with the reals and the imaginary with the imaginary. 6 minus 2 is 4. 8i plus 5i is 13i. That's your complex number when you're doing the differences. But again, be careful. You have to make sure you distribute that negative symbol because of the parentheses. Okay. Go ahead and give those two a try. You can find the solutions for those two. So the first one we're just adding, so we're just going to combine the reals and the imaginaries. So we've got negative 6 minus 3i. Second one, I'm just going to rewrite it. 3 minus 2i. Distribute that in there. That gives me plus 4 minus I 3 plus 4 is 7. Negative 2 minus 1 is negative 3. Any questions with that? Adding and subtracting, okay? So the next thing then we want to be able to do is we want to be able to multiply them. So when we multiply them, end result, when we multiply, always needs to be in the form a plus bi when we're done with this. All right, so let's look at the first one. We've got negative 2.5i, and then in parentheses, 8 minus 9i. And again, we're going to think about this as multiplication. If I was going to multiply 2.5x times 8, we distribute. And that's what you do. You're going to distribute. Multiply reals times reals. Negative 2.5 times 8. That's negative 20. That gives us negative 20i. Now we have to take and distribute that negative 2i times negative 9i. So 2.5 times 9 is positive 22.5. What's I times I? I squared. Okay, so, Does everybody see how I got that part of it? We're not done. We got to fix it more, but we're done. So we said earlier that I is equal to the square root of negative 1, right? If I take I and I square it, if I square one side of an equation, what do I have to do to the other side? I have to square the other side of the equation as well. What happens to the radical and the square? They cancel out. So what does I squared equal? I squared is equal to negative 1. That needs to be in your notes. I squared is equal to negative 1. So now knowing the fact that I squared is equal to negative 1, this becomes negative 20i plus 22.5 times negative 1, which is negative 22.5, right? Also keep in fact that we have to have the real number followed by the imaginary number. So I'm going to rewrite this negative 22.5 minus 20i. The real number has to come first, followed by the imaginary number. It will cost you about 1/4 of a point on a test if you don't have it written in that form. Needs to be written in that form. Okay? And again, I squared is negative 1. I squared is negative 1. I squared is negative 1. So let's look at the next one. So we've got 3 minus 2i times 3 plus 2i. So now I've got essentially two complex numbers that we're multiplying together. You have to FOIL it. We have to go first times the first. 3 times 3 is 9. We have to go outside times outside. So 3 times 2i is 6i. Inside, negative 2i times 3 is negative 6i. And then last, negative 2i times 2i is negative 4i squared. So now if I rewrite this, this is 9. What happens to the i's? 6i and negative 6i, they go away. So this would be negative 4i squared, but I squared is equal to negative 1. So this is going to be 9 plus 4, which is equal to 13. So that's your solution to that. Now, obviously, that's not always going to be the case when you multiply two complex numbers together. It's not just always going to be just a real number. This works because your eyes are opposites of each other. Okay. But remember to FOIL when you're doing that. Give those two a shot. Multiply those out, see what you get. Maybe about another minute. All right, first one, multiplying fractions. So we've got 2/5, so that's 20/5, so 4i. Uh, 2/5 times 5/2. That's probably just 1, right? So negative 1i squared. I squared is negative 1. So this would be 4i plus 1. So 1 plus 4i. Second one, can we agree that the middle terms are going to go away? How do I know the middle terms are going to go away? Because you've got plus 2i and minus 2i. So the middle terms are going to go away. Plus, and it's a half and a half. So a half times a half is a fourth. 2i times 2i. 2i times negative 2i is negative 4i squared. So that's 1/4 plus 4, which is 4 1/4, which is 17 over 4, which is 8.5 over 2, which is 4.25, which I could care less which one you put. Okay, don't put that one. So how do you finish it up today? Remember, square root of negative 1 is I. I squared is equal to negative 1. When you're adding them or subtracting them, combine likes. Reals with reals, imaginary with imaginary. When you're multiplying them, you get that I squared. Make sure you change that I squared into negative 1. When you're going through your assignment today, make sure that you pay attention to the ones that you are supposed to do.